So hello everyone, welcome to all of you, and this tutorial we are going to learn about this PyVista tool. So this tutorial is generally used to do the post processing. Okay, so this PyVista is not particularly made for the OpenFOAM, because this PyVista you can use for any kind of the 3D plotting and mesh analysis through a streamlined interface for the visualization toolkit. Okay, so if you have any file with the extension of the VTK that you can use for the plotting and mesh analysis for that VTK file. Okay, so this VTK is not made for the OpenFOAM, but of course since OpenFOAM file you can also export as a VTK, so you can use some of the commands, and by using those some of the commands you can do the post processing for the your OpenFOAM test case. Okay, so that I am going to show you, and there is advantage of using this PyVista, so that in some cases if your file size is very large and your ParaView is not able to export that file, in that scenario you can use your PyVista scripting, and that file you can easily do the post processing analysis. And another advantage is that nowadays people are more focusing on the machine learning modeling or neural network training. So what happens that in that scenario you cannot like create lots of data using the ParaView. Okay, of course you can do the Python scripting in ParaView, but as per my experience I see that ParaView used to get crashed if you are handling like 500 test cases or 1000 test cases. So what happens in that scenario, this PyVista utility you can use for such scenario. So if you want to generate the lots of data, in that scenario you can use the PyVista utility. So here we are going to see that how you can use the PyVista utility. So this page you can go and you can see some of the introduction about the PyVista. Okay, now I hope that if you are following my videos, so we have already installed the Jupyter notebook. Okay, so we are going to use a Jupyter notebook to get the idea about the PyVista. Okay, of course, like if you learn how to do the scripting in Jupyter notebook, then you can of course like write that any script and you can use .py scripting for your automatization purpose. Okay, so that we are going to do that, how means like you can do the automatization of your Python script for your test case. Okay, so we will do all these things in this tutorial. Okay, so here I have opened Jupyter notebook. Okay, so sorry, this should be PyVista. Okay, so if you want to install this, you can just run this command. So you can just copy from here and you can just run it. Okay, so it's saying that so I have already installed this PyVista, so that's why it is suggesting that this requirement has been already satisfied. Okay, now you can check that whether this PyVista is installed or not, so that we can check like okay, so it should print the version. So in my scenario I have 0.463 version. Okay, so currently the version is 0.46.4, but in my scenario this is the one version previous. So now I have imported this PyVista. Now I can go to the our WSL location and we can take any test case. Okay, and we can learn that how we can use the PyVista for post processing. So this is like I have installed OpenFOAM inside my WSL. So I can go to the my WSL and this is where I have like one test case. Okay, so maybe I can take this speeds daily test case. Now you should keep in mind that whichever folder you want to access, or if you want to do the post processing, there should be one file with the extension of the .foam, that is the FOAM. Okay, now how you can create that .foam extension? So for that purpose you can just go to that folder. Okay, maybe okay, so you can go to the that folder. Now you can use the touch command and touch dot any, like any file number you can give here, and you should have just keep in mind that this .foam extension should be present here. Okay, so you can see that this .foam extension should be present here. Now this file we are going to export using this PyVista. Okay, so let's take that PITS daily case. So we have imported this PyVista as PV. So we can just call this method, that is the foam reader of this PyVista, and after that I am going to give the location of this folder, so that we can take from here. So you can, if you press Ctrl N, it will give you the, like you can copy the location from here and you can put here, and we can take any .foam that is present inside this folder. Okay, so once you exported your case, now you can read the different things related to the this case. Okay, so like if you want to read the mesh, that you can read using this case dot read function. Okay, now this mesh of this case is exported as a object as a mesh. Okay, now you can see that you are able to read this mesh, like this as the number of block equal to the 2, and the x bound is like this is the minimum x and this is the maximum x, this is the minimum y, this is the maximum y, this is the minimum z and this is the maximum z. Now it is suggesting that the number of block equal to the 2, that does not mean that mesh has only 2 blocks. So this 2 represents the these things. Okay, so like you can see that index 1 is having the internal mesh, and index 1 has the boundary. Okay, so if you want to see further, so if I put here mesh.0, so you can see that it is suggesting me all the properties related to the internal mesh. Okay, so this is suggesting that this mesh.0 is the completely internal fields. Okay, and it is suggesting that the number of cells equal to the, this is the number of total cells, this is the number of points, this is the bounding box of the x, this is the bounding box of the y. Now it is suggesting that it has a total 18 arrays. Okay, and this total 18 arrays are these points. Okay, so you can see that 1 2 3, and you can count that this will be total 11 values. Okay, now if you see dot mesh.1, okay, so you can see that mesh.1 is all the information related to the boundary fields. Okay, and now here total blocks is the 5 blocks. So if you want to access only the internal like inlet, so that you can mesh start 1 equal to the 0 you can suggest, and again you can see that mesh dot 1, that is the inlet boundary patch, has total number of cell equal to the 30s, total number of points equal to the 62, and total number of arrays equal to the 18. Okay, so this way you can see that how like different value you can access. Like if you want to access like some other boundary field, so this way you can access, like we have total number of cells equal to the 57 and total number of points equal to the 116. Okay, so this way you can like access the different information of the internal mesh and the boundary patches. Okay, now like if you suppose if you want to know the what is the different bounding box of this open like your mesh boundary, so if you want to know that what is the bounding of the this mesh, so that you can access like mesh dot bounds. Okay, so you can see that you have like x min equal to the this value, x max is equal to the this value, y min is this, y max is equal to the this, z min equal to the this. Okay, now suppose just you want to know the you want to access the x min, similarly if you want to access the like x max, y min, so that you can use the indexing here. Okay, so like mesh dot bounds, this 0 will is going to give me the x min. Okay, so if I only want to like use this x min, similarly if I want to use that x max, similarly if I want only access the y min. Okay, so this indexing starting from the 0, 1, 2, 3, 4 and 5, you can access the different min and max of the x axis, y axis and z axis. Okay, so if I show you here, you can see that this is the x min, this is the y x max, this is the y min, and similarly you can x for the y min, y max, z min and z max. Okay, so this is how you can access the different like different meshing bounding box of the your meshing. Now if I ask you that suppose if you want to access only the bounding box of your internal mesh. Okay, no, not internal mesh, suppose if you want to access the bounding box for the your inlet patch, so you can use this way, and you can see that this is suggesting me the bounding box for the inlet patch. And how you can know that like this indexing is for the inlet or this indexing is for the outlet. So, this I have already told you that mesh, if you print the mesh, it is suggesting me that 0 is for the inlet internal mesh and 1 is for the boundary. Okay, so if I put here mesh dot 1, it is going to suggest me that different indexing for the different bounding box. Now suppose if I want to like check that what is the bounding box for the upper wall. Okay, so this way I can like put the bounds. Okay, so this will show me that different x min, x max, y min, y max, z min and z max. So this is the bounds for the my what is the this is the upper wall. So this is the bounds for the upper wall. Okay, so I think now you have like idea that how this bounds you can access. Okay, now this is just like different this is just I have explained that how you can access the different information for your OpenFOAM case. Okay, now like the most important thing that we are going to see that can we also access this internal mesh and boundary using this name also. Okay, so like suppose you don't know that what is the index of this internal and boundary mesh. Sometimes like we just want to call this name only. Okay, so you can also access this information using the internal mesh. Okay, so what I mean to say that, so if I put here like, and I just call this internal mesh. Okay, so this way you can also access your information using the PyVista. Okay, so if I keep here internal mesh, so I can access this information here. Okay, so if I print here this internal mesh, so it is going to like give me this complete information related to the internal mesh. Okay, so you can see that this is the unstructured grid, number of cells equal to the this, number of point equal to the this, and these are the total x, y and z points, and total we have a around 18 arrays. Okay, so this way you can like access the different information of the OpenFOAM. Okay, now this is all about the accessing the internal mesh and the boundary patches. Now suppose if you want to access the particularly time step, or if you want to access that what are the different time access is well used, so for that purpose you have to just go to the go to read this case. Okay, case and dot time values. Okay, so this is okay, I think there is some error, let me check. Okay, so this is the function that we are going to use, that is the time values. Okay, so this we are going to use, so see that what are the different time values. Okay, so you can see that we have like 0, and this is the iteration 100, this is iteration 200, this is iteration 287. So this values we can access here. So like we can store in some list, maybe in time equal to the, we can store this different times within a list that is equal to the time, and we can access this for the, so this is going to the 0 time step, this is going to give the 1 time step. Since our solution is the steady state, so we want to do the post processing for the last time step. Okay, so we need to access that time step value. Okay, so if you see that, so we have like different time step, this is the 0, 1, 2, 3. So we need to do the post processing for the final time step. Okay, now let me just set this time value. So the active time value should be, which is the final time step, that is the 3. Okay, so this will set this time step value, that is the 287. So we want to do the post processing for the final time step. Now after that we want to read the mesh. Okay, so that is going to give the mesh for the final time step. So now we want to do the post processing for this time step only. Okay, so if I run here, so this mesh one will access the information for the time equal to the 3, that is the 287. Okay, now since we want to do the slicing, and we want to do the slicing of the midway of the z bounds, so now we have to give the information of the normal. Okay, so along which we want to do the slicing. So we want to do the slicing along the z axis, so that is why here this value should be the 1. Okay, otherwise you can put, if you want to do the along y axis, then you can do here 1, and other this will be 0, and similarly for the x axis. Now this is the important that we want to like give here the origin. Okay, so if you remember, like in ParaView we need to give this two information, that is the normal and the origin to do the slicing. Okay, now the value of this origin will be this value, that is the midway of the x, midway of the y, and midway of the z. And if I run this, we have this slice mesh. And if I want to print the slice mesh, then you can see that now this z bound is the 0, because we are doing the slicing along the mid of this z. You can see that this slice one has the internal mesh as well as the boundary field also. Okay, so this way you can, like, if you want, you can plot this slice mesh. Okay, so for the plotting purpose, we can just like search this PyVista as CFD, and you can like read the different things that how you can do the plotting. So suppose, so for the plotting purpose, generally this plotter utility is used. Okay, so this p1 equal to the pb dot plotter that we are going to use. Okay, now like we can call this function. Okay, so this we are going to use to plot the velocity, and maybe we can like remove this. This is not required for our purpose. Instead that we can like use the cmap utility, and maybe we use the color, that is the JET. So you can see this cmap just by googling what are the different cmap available in the PyVista, and instead of the this y slice, we should have the this slice mesh. And now we can use the p1 show, and you can see that we have this kind of contour. Okay, now we can, if we just want to the view the xy plane, so that way we can do this way. Okay, sorry, this p2. Okay, so you can see that we have only contour plot for the u. Similarly, we can plot for the p. So this is the contour plot for the pressure field. Okay, so that way you can like do the post processing also. So this is just for the illustration purpose. Now what is the advantage of knowing this code, this PyVista, that you can like automatize your post processing. Okay, what I mean to say that, suppose I have this access, this test case, and maybe like I want to do this post processes for the all the time step. Okay, so I can write like for t in time. Okay, so I want to do the post processing for the all the time steps, and case dot set. So I can write these things, that is the these two things I can just call that for the different time steps do these things. Okay, so case dot set active value dot time equal to the, this needs to be put here, that is the t. So it is going to read the mesh for that time step value, and this information we are going to use for the slicing purpose. Okay, so this we are going to use for the slicing purpose, and this is going to do the slicing. Okay, so this is going to do the slicing for the or this mesh one. Okay, and this we are going to use for the plotting purpose. Okay, so instead of instead of the like show, we can save. We want to save. Okay, so we want to save the different files with the name of the time name only. Okay, so this we are going to do. Okay, so see, you can just do the automatization of your post processing. Okay, so just we are doing for the scalar field p, and again if you want to do for the like other fields also, so similarly you can do here u. Okay, and that way you can like write your different Python script, and you can do the post processing of all those cases. Okay, now if you want to see here, okay, so I think it is at the different location. So let me see that whether I can able to find this or not. Yes, so by mistake it is at this location. So you can see that this is for the time equal to the 0, this is for the first iteration, this is for the second iteration, and this is the final iteration. So that way you can do the post processing and other things. Okay, so this is just illustration. Now like you can know that what is the capability of, like here I have given a single case. Similarly, if you have a number of cases, so that way you can also do the like post processing for the number of cases. And as I show you that you can do the post processing for the number of time steps, that you can also do. If you want to do the like do some calculation also, you can also do here. So that way you can know the this capability of this PyVista. Okay, so you can do the a lot of things using this PyVista, and this is just one illustration here, and you can have a other things also. Okay, so I hope you understand this PyVista, and if you want to like some specific automatization to your post processing, you want a video of something like that, you can just comment those things in my like YouTube comments, and I will surely try to create one video for that particular function. Okay, so I hope you like this video. Thank you for watching.